Alright guys, we are now looking at our KC7 review. So starting with target 7a, 7a is all about our Pythagorean theorem. Okay, so we have a squared plus b squared equals c squared. Remember, the biggest thing we have is c is across from your right angle. Okay, so when using Pythagorean theorem, right, we have to make sure we know where that hypotenuse is. And then our legs are just a and b, or the opposite and the adjacent side, right, are just a and b. So yeah, we're using that a squared plus b squared equals c squared. So I have 9, I guess I put a as 12. 12 squared plus 9 squared equals c squared. 12 squared is 144. 9 squared is 81. These are on the same side, so I'm just adding them together. That's one of the biggest mistakes I've seen is people like trying to subtract here. Hey, remember, I'm always subtracting to get things away from the variable. But my variable is over here. So it's just 144 plus 81, which is 225. And then I'm going to take the square root, right, to solve for c, and c equals 15 feet. And that's it. Let's look at number 2. In the following picture, find the exact height the ladder reaches. Round your answer to the nearest hundredth. Okay, so if we have to round, we can. Again, we have to start with our right angle. Remember, the right angle always looks like a wall and the floor meeting. Some of us are still confused about what right angles are. Okay, we'll try to draw a right angle here. No, it's straight up and down, straight across. That's what makes right angles. So, in the following picture, find the exact height that the ladder reaches. So again, my hypotenuse, my c, is across, and then I have a and b. So here when I'm doing a squared plus b squared equals c squared, I have 6 squared plus h squared equals 14 squared. 6 squared is 36. 14 squared is, I believe, 196. Yes. Now, in this one, 36 and 196 are on opposite sides. That's when I have to do the opposite. So those cancel. So h squared equals 160. And then I'm going to take the square root. So h equals, the square root of 160 is 12.6491. It does tell me to round to the nearest hundredth, which is 2 decimal places. So 12.65. Keep wanting to press that button. And this is meters. All right, looking at number 3, Rhonda is planning a right triangular garden. She marked 2 sides that measure 27 feet and 7 feet. What is the length of side N? So again, here is my right angle. Across from that is C. It's hard to see with the flowers in the way. All right, and then I have A and B. So again, I have A squared plus B squared equals C squared. N squared plus 7 squared equals 27 squared. N squared plus 7 squared is 49. 27 squared is 729. So 49 equals 729. I'm going to subtract 49, right, because 49 and 729 are on opposite sides. So n squared equals 680, I believe. Minus 49. Yeah. And then I'm going to take the square root, right, of 680. And I get 26.0. We'll round up to 8. All right, let's look at number 4. Number 4 is a problem we looked at in our notes, right? In construction, floor space must be planned for staircases. If the vertical distance between the first and second floors is 375 centimeters, and a contractor is using the standard step pattern of 30 centimeters wide for 15 centimeters high. A, how many steps are needed to get from the first to the second floor? Okay. So I'm going to draw my lovely, right, here is my staircase, right, and I have the stairs going up it, right? I know it's 375 centimeters, and each step is 15 centimeters high. And 30 centimeters wide. So how many steps do you need to get from the first to the second floor? Well, remember, your number of steps times the height will equal the total height, right? So the number of steps I have times the height of each step will equal my total height. So number of steps is what I'm looking for. So x times the height is 15, and my total height is 375. I'm going to divide both sides by 15. So x equals whatever 375 divided by 15 is. Divided by 15. 25. Okay? So this is going to have 25 steps. Next question, how much horizontal distance will be needed for the staircase? So same thing, number of steps times the horizontal, or we're just going to call it the width of each step, will equal the total width. So now I know I have 25 steps, and I know the width is 30. Will equal my total width. And 25 times 30 equals 750. So 750 centimeters equals the total width. C, what is the length of the railing? Okay. I'm going to move this up a little bit. So my railing, right, is going along here. That's what I'm looking for. Okay, so now I can use my Pythagorean's theorem. X is C, I just have an A and a B. Okay, so I have A squared plus B squared equals C squared. A is 750, B is 375. 750 squared is 562,500. 562,000 plus 375 squared equals 140,625. 140,625. There we go. Equals C. That's supposed to be a 2. Okay, so again, my two numbers here are on the same side. Okay, so I'm just going to add those together. So 562, 500 plus 140,625. And we get 703,125. And then my last step is to take the square root. I'm just going to write it over here to be easier. So when I take the square root of 703,125. We get 838.5. centimeters. And that's it. All right, our last question, number 5. A baseball diamond is actually a square with sides of 27 meters. If a runner tries to steal second base, how far must the catcher at home plate throw to get the runner out? Given this information, explain why runners more often try to steal second base than third. So I'm going to draw our baseball diamond. And it has sides of 27 meters. How far must the catcher at home plate throw to get the runner? The runner tries to steal second, right? So I have home, first, second, third. So if I'm the catcher at home and a runner steals second, I have to throw that distance. Okay. So that's my X. Now, again, we're always looking for our right triangle. Again, this told me it's a square, so this is actually a right angle. Squares have right angles. Right? So there's my right triangle. I'm looking for my hypotenuse, and I have A and B here. Okay. A squared plus B squared equals C squared. A is 27, B is 27, and C is just what I'm looking for. 7 squared is 729. And 729, these are on the same side, so again, I'm just combining them. And you get 1458. 1458, yes. Then, right, to solve for x, I just take the square root. The square root of 1458 is about 38.2. We'll round it to. All right, now that we have that, I need my explanation, right? It is asking, given this information, explain why runners more often try to steal second base than third. That is part of your points. If you don't write this explanation, you will get points off on the test. So, runners steal second because the throw for the catcher .2 meters is longer than the throw to third. Alright, the throw to third is just this basic 27 meters. Okay, so it's easier for the runner, right? The catcher has to throw longer. It's going to take the ball longer to get to second than it does for third. All right, that's it. Go ahead, look over that, and then look at target B.